Hi Calculus, I'm back with curve sketching. This is now example 2. I'm going to try to give you 3 examples. I have to just watch the time frame so that the video doesn't cut off. Please understand that when you do this section on test 3, that I am not expecting you to do the derivatives. That was test 2. Test 3 is that you know how the derivatives apply to sketching or how the derivatives apply to solving some kind of equation. But specifically here on these sketches, you'll notice these derivatives can get quite sophisticated, and you're not expected to do them. You're just expected to apply them. So let's go ahead now and apply them. So the first thing you want to think about is, what is the domain of my graph? So as I look at this, these are cube roots, and cube roots, the domain of cube roots is all real numbers. So there is no restriction of x values in this particular graph. If there was, then I would have to use that information in the first and second derivative. Now I'll go right ahead and find my critical number and my critical point. Critical numbers occur when the numerator is equal to 0 and when the denominator is equal to 0, assuming that that is not a domain restriction. So the numerator is equal to 0 at -1. The denominator is equal to 0 at 0 for this one and -3 for this one. Again, none of these numbers are domain restrictions because my domain is all real. The critical points follow the same idea. You figure out when the numerator is equal to 0. In this case, that's impossible. There's no variable up here, so the numerator cannot equal 0. But I have to also look at when the denominator is equal to 0. So x is equal to 0 and -3. It is just fine if there are the same points in both of these categories. Okay, that is not a problem. It's just a problem when they're a domain restriction. I'm now going to analyze the first derivative. So I'm going to work on that. I may set this one up a little differently just so I have a little more space. I guess I don't. Okay, I'll have to come over here. I'm going to now analyze the first derivative. I'm going to put down my critical numbers. I'm going to put test values in between them. When I plug into this, I'm first going to just take a moment to see if anything is always positive or always negative. Since this quantity right here is being squared, that means that that output will always be positive. So I know that this output will always be positive because this quantity is being squared. Because this, oh no, that's the second one is to the 1/3. Okay, so that's to the 1/3, so that can be positive or negative. That can be positive or negative. All right, so that's all I got on this one in terms of being consistent with the sign of the output. I'm going to go ahead and plug in. -4 plus 1 is -3, so it's negative in the numerator. That one's always positive. -4 plus 3, that's going to be -1. And if you cube root negative, it's negative. If you cube root a positive, it's positive. Okay, so that's going to be negative. So I have a negative over a positive over a negative, so overall that's negative. Sorry, overall that's positive, because I have 2 negatives. Okay, first derivative, we're going up on that segment. -2, so I've put -2 into the numerator, that's negative. This part's always positive. -2 here is going to be positive. So negative, positive, positive is negative. That guy's coming down. Okay, I'm going to put in a half here. A half, that's positive. That guy's always positive. That guy's positive. It's positive. That means that segment's going up. Okay, last one, I put in a 1. Positive, 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 positive. All right, this is going to keep going up. So once I figure out my increasing, decreasing behavior, I now go in to look for relative extrema. So around this critical number, it goes up, then it goes down. So right here I have a relative max. So the input value is a -3. Again, make sure you plug that into the original. If you plug a -3 into the original, this piece goes to 0. And 0 times anything is 0. So that means that this is going to be an output of 0. All right, so that's what happens around that critical number. Around this critical number, we go down and then we come up. So this is a relative min at -1. Again, that has to go into here. This one's a little more sophisticated. So let's see, -1. So this means you're taking the cube root of -1. This means you're doing -1 plus 3. You're doing that to the cube root and then squaring it, or whichever order you want to do that in. You can square it first. So this means that it's the cube root of -1. -1 plus 3 is 2. So you're doing 2 squared. You're doing 2 squared, which is going to end up being 4. So we all know that the cube root of -1 is -1. Let me just simplify that already. So then this doesn't simplify, because this is going to end up being 4 to the 1/3. Meaning, let me write that better. It's negative cube root of 4. Negative cube root of 4. Okay, so that we've got to put in the calculator. So I'm going to do negative. I have this key here. This lets me do a cube root. This guy here. You can also like raise it if you want to the 1/3, if that's easier for you. So I'm going to do. Oh, that might be easier for everybody. Let me just go ahead and do that. So I'm going to take the 4 and I'm going to raise it. See, I'm raising it to the 1 divided by 3. That'll give you the same answer. That might be easier for you guys to see. So that's about, I'm just going to do 1 decimal. So I'm going to round that to -1.6. -1.6. -1.6. At 0, the graph goes up, and then it keeps going up, so there's no relative extrema there. So that's all we got. We got a min and a max, and we're good there. On to the second derivative. Okay, over here, let's see what's happening in terms of behavior, in terms of concavity and inflection points. I personally like to line this up when I can. 0 is about here. 3 is about here. -3 is about here. Okay, so these now are critical points. We're now analyzing them as critical points. I'm going to pick test values. I'm going to look at where things are constant. So this guy is always going to be negative. That's really important you catch that, otherwise all your signs will be opposite. This guy right here, since it's to the 4th power, will always be positive. So this this one here is the only one that can change sign. So this I'll put in. So the if you plug a -4 into here and you take the cube root and you raise it to the 5th, it'll stay negative. So I've got a negative over a negative times a positive, so overall that's positive. That means this is concave up. If I plug in a -1, that's going to be negative. Again, if you put a negative and you cube root it in 5th power, that's going to stay negative. So this guy's positive. This guy's also concave up. Okay, if I put in a 1, that's negative, that's positive. This is going to be positive. So it's a negative over a positive, which is negative. Concave down. All right, so let's see what we got. To the left of this critical point, it's concave up. To the right of this critical point, it is still concave up, so there is no inflection point here. To the left of this critical point, it's concave up. To the right, it's concave down. So that means that right here, we've got a winner. So make sure again that you plug that 0 into the original. And that means that this part will become 0, and 0 times anything is 0. So this is 0, 0 in terms of an XY coordinate. Okay, awesome, gang. So let's graph this. Take a moment to look what your numbers are. Like I got -3, 0, -1, -1.6, and 0, 0. I mean, my numbers are relatively small. So I don't want this graph to be like fitting on a grain of rice, right? You want to like stretch things out so you can see it, right? So let me see here. So I'm gonna, you know, I want to stretch this out so I can see it. I'm not trying to draw this on like a grain of rice. Okay, let's see what this beauty looks like. I'm going to put down my values. -3, 0. This guy right here is a relative max. -1, -1.6. -1, -1.6. This is a relative min. 0, 0. That's an inflection point. All right, that's all my data points. Now I'm just going to follow the information here to draw this graph. So it says, the information says to me that I should be increasing. I should be coming up to the relative max, right? So I should be below it. I should be increasing to the relative max, and as I'm going up, not only am I increasing, I'm concave up as I'm increasing. Concave up as you're increasing looks like this. Concave up as you're increasing looks like this. I gotta hold water as I go up. Once I hit that max, I start to decrease. As I'm decreasing, I'm still concave up, and I'm going to do that all the way to my next value, which is actually here. So I'm going to stay concave up till I hit my next value, which is right here. Okay, so that means on this graph I have to stay concave up as I come down. I'm concave up as I come down. Holding water, concave up. I hit my relative min here. Then I start increasing. As I'm increasing, I'm concave up. This happens simultaneously. I'm staying concave up. Now I hit my inflection point at 0. I go concave down, and I increase. I'm increasing as I'm concave down. So increasing as I'm concave down looks like that. I'm going up, but I'm dropping water as I'm going up. Okay, gang, that is the graph. I hope that helped. I'll catch you again for one more example. Bye-bye.